Hey everyone, welcome back to the Energy Blueprint podcast. I am here yet again for the now fourth time with Dr. Chris Masterjohn. Quick intro for him. If you guys haven't listened to the previous podcasts, he's got a PhD in nutritional sciences, and he's widely recognized as one of the world's top experts in nutritional biochemistry. Okay, last topic I want to shift to is neurotransmitters. This is obviously a very, very big topic. I know you could talk for hours on this topic. I want to just kind of give people maybe a few key tips from your body of knowledge on maybe some, common deficiencies of certain neurotransmitters that result from various nutritional deficiencies and how that might play out, and then how to correct some of those things. Also, I want to make sure we talk about GABA in particular, because I know you've done some good work around that subject recently. So I'll let you kind of maybe give a broad overview of the relationship of some of these neurotransmitters and how nutrition impacts on them.
You want me to talk about the neurotransmitters or go straight to the nutrition?
Just if you could do a very brief overview, high-level overview of what the neurotransmitters are doing.
Sure. So there's over 100 neurotransmitters. They are broken down into a handful of classes. So neuropeptides are neurotransmitters that are 3 to 36 amino acids big, you could say long, and amino acids are the building blocks of protein. So these are all derived from protein. About half of them are biologically activated using vitamin C, copper, and zinc. And these neuropeptides do all kinds of things. There's so many of them that it depends what you're talking about, but preventing you from waking up in the middle of the night to pee is one, supporting the affectionate response to physical intimacy is another, regulating your appetite, preventing you from eating too much, regulating your pain response, preventing chronic pain, supporting your libido, supporting your thyroid hormones, your sex hormones, and your adrenal hormones are all examples of things that these neuropeptides are doing. Then there are amino acids, which are the single building blocks of protein or neuropeptides. Single amino acids include glutamate, which is the primary excitatory neurotransmitter, GABA, which is the primary inhibitory neurotransmitter, and glycine, which is sort of the number 2 inhibitory neurotransmitter. You could say as a general oversimplification that an excitatory neurotransmitter such as glutamate is going to get you revved up, and inhibitory neurotransmitters like GABA or glycine are going to calm you down. But that is an oversimplification. When you talk about excitation inhibition, you're just talking about turning a neuron on or off. And so, glutamate is one of the major things that's helping your senses be perceived, because, if light comes into your eye, well, in that case, you actually have to shut off glutamate production that communicates darkness. But either way, taking these senses in generally requires glutamate making a neuron fire in one way or another. And also GABA, even though it's an inhibitory neurotransmitter, GABA is part of what helps you be alert and focused on something that you actually need your brain turned on for. And that's because when you focus on something, part of what helps you focus on that thing is to shut off all the distractions. And you actually have a constant production of GABA that is constantly suppressing all of the things that you're not paying attention to. And if you took out that GABA response completely, you would be paying attention to everything, and you would become certifiably insane very quickly. But if you just lower the GABA a little bit, then you're going to wind up with ADHD or some kind of, just major distraction problem on your hands. And then there are the biogenic amines. The biogenic amines include dopamine, norepinephrine, epinephrine, serotonin, and histamine. Norepinephrine and epinephrine are also called adrenaline and noradrenaline. And dopamine, often misperceived as a pleasure chemical, is a motivation chemical. Dopamine is what signals value to invest energy in doing anything, whether it's a physical thing like movement or even keeping steady, right? So in Parkinson's, loss of dopamine can cause the tremors. And that's because you're not investing energy in quieting those muscles and making the motions controlled. But it's also your signaling value that, me talking to Ari right now is of enough value that I'm doing that thing, and I'm not on Facebook behind you. You know, even Facebook is like right there because I'm recording this on my computer. Like I'm
Everybody listening to this right now better not be on Facebook.
Yeah, so I'm not on Facebook because of GABA, but I am talking to Ari because of dopamine. But then when I'm talking to Ari because of dopamine, I am using acetylcholine to get the fruit of the labor, right? So dopamine motivated me to talk to Ari. Acetylcholine started firing deep in here to get all that learning and memory and processing and digging into my analysis that I had before. All that stuff is acetylcholine. So sustained focused attention is one of the major things that acetylcholine is doing. Serotonin, often misperceived as a feel-good chemical, is a stress coping chemical. And you need some serotonin in your brain and your gut in order for things to move along like they should, in your brain to be able to not feel overwhelmed. If you have too much serotonin in your gut, it causes diarrhea to cope with the stress of something being in your gut that your body thinks shouldn't be, and so gets it out. Serotonin also causes you to avoid your fears. And so the higher your serotonin is, the more of a wimp you're going to be. Serotonin also, if reality is stressful enough serotonin can allow you to cope with that reality by not being part of it anymore. And so LSD causes hallucinations by acting on a subset of serotonin receptors. And one of the hypotheses of schizophrenia is that the onset is caused by a stress-induced spike in serotonin that is, severe enough to cause that level of coping with that reality to just leave it.
Wow.
Yeah. So, but if you don't have enough serotonin, you're gonna feel overwhelmed, and if you feel overwhelmed, you're gonna be vulnerable to depression and anxiety and other things like that. Norepinephrine and epinephrine are both important in the central nervous system, but norepinephrine is much more important. When these things are produced by the adrenal gland, you're going to produce a lot more of the epinephrine and less of the norepinephrine. In the nervous system, you're producing more norepinephrine. And norepinephrine is one of the things it does is help you explore your options and decide which thing to latch on to start exploiting as an option. Now, all of the biogenic amines play a role in histamine. Histamine is an alertness chemical. Too much histamine causes anxiety, could cause a panic attack. But like, if you didn't have a histamine right now, you'd be sleeping. And that's why you take Benadryl as an antihistamine. Enough of it gets into the brain to knock you out. All of these things are waking signals. And then so is acetylcholine. Acetylcholine doesn't belong in any of the previous categories. Acetylcholine is actually, I did mention it a minute ago. It's not considered a biogenic amine. I apologize for that. Acetylcholine and the biogenic amines are all part of the waking signals. And when you're sleeping, they all shut off for the most part, except acetylcholine shuts off during deep sleep, but spikes during REM sleep. So I think that's a general overview of what these things are doing. Overview of nutrition, how to support them. There are some very general things that you could say.
I want to narrow this because I know that this could be a huge, very long discussion. I want to talk specifically about dopamine and GABA, just as some cool ones, I think.
Okay.
If you could talk about how nutrition relates to those.
Yeah. Okay, cool. There's a few things to say about dopamine. One is you need to produce dopamine. And when you produce dopamine, you start with tyrosine, and you are using basically a bunch of the B vitamins that include B vitamins involved in energy metabolism and B vitamins involved in methylation. And then you're also using a few minerals. So you're using copper and iron. You are using vitamin B6. You might be using ascorbate. You might be using zinc, and you might be using salt. And this is all based on everything I said might is based on animal research. And you are definitely using methylation not methylation in the production of dopamine. Another thing is that the whole production of dopamine is going to be hurt by oxidative stress. And so that kind of goes back to the things we talked about before about antioxidant protection. I think there are some people that are not making enough dopamine. But I think the more common issue with dopamine is how it's regulated. And so the place where methylation comes in is not in producing the dopamine, it's in regulating it. And to keep it short and simple, the more methylation you have, the more you regulate dopamine in a way that makes you mentally flexible. And the less methylation you have, the more you regulate dopamine in a way that makes you mentally rigid. And within the middle of the spectrum, that's just a personality trait. But on the poles of the spectrum, you can become pathologically neurotic or psychotic on either end. And so even in schizophrenia, you see some schizophrenia, some people have this symptom called rigidity of thought, and other people have the symptom called flight of ideas. And those are on the psychotic poles of too much mental flexibility, too much mental stability or rigidity. Mm-hmm. And, in the middle, you can become like kind of neurotic because either you're constantly distracted and you can't focus, or you're constantly ruminating on things. And, there's a trade-off. Like, you may be ruminating on things that are highly productive, and that might get you like very good fruits in your material success and the success of your career and the success of the ideas you create, because you're so good at focusing.
If you're obsessed with a particular topic and you just spend years studying it and you become an expert on it and potentially, make it into a career, and because you're such an expert on it, then it becomes something very lucrative.
Yeah, but if you're obsessed with the girl that said no to you for when you asked her on a date 7 years ago, that's going to play out differently, right?
Yeah.
And so to a certain extent, it's the same cause of both those things, mm-hmm. because what this is impacting is the degree of obsessiveness. And hey, if you're obsessed with the love of your life, and you're completely devoted to her, she might really like that, right? Mm-hmm. The obsession, it's not the obsessiveness that's the problem. It's whether you can control what you're obsessed with.
Yeah.
If you are too far on the path of obsessiveness, it's going to get harder and harder and harder to control what you are obsessed with. And you are more likely to become a victim of it. But, you can use nutrition and good psychological techniques to rip you right back here. And that's where you're like, oh, I'm just going to obsess on the love of my life and on my passion career. And, everything is great, right? Mm-hmm. And you're going to be a different person in work and in love than you would be if you were on the other side of that, where you just like something comes up and like, oh yeah, I can do that for you, honey. And then like you're thinking about Mario Kart 5 seconds later, like, that's going to be a different and that's, maybe on one end of that, right? But there's going to be personality traits, and you're going to interact with people and your career differently if you're more on the obsessive side or more on the flexible side. But like, you're going to be a better CEO if you're more on the mentally flexible side, right? Like, how many decisions every day does Jeff Bezos have to make? I think someone tried to count it before, like it's in the upper hundreds or something like that. But like, so if you're, someone like me has to do all of it, and I'm a better content producer than I am the CEO of my company, but I still have to do both.
Yeah, likewise, I'm with you.
Yeah. So that's dopamine. And methylation, when it comes down to nutrients, is more methylation to make you more mentally flexible is going to be things like folate, B12, and choline. In order to prevent you from going too mentally flexible, glycine is going to be the biggest thing. So glycine could theoretically calm down those distractions. Now GABA is of course going to be like, if you're focusing on something because of dopamine, you're going to have to use GABA to shut off everything else. But you also need GABA to stay calm. A lot of psychiatric diseases involve too much glutamate, not enough GABA. Seizures is a definite place where that comes into play. So there's quite a few things to say on GABA. The only nutritional thing that has ever been shown to very clearly raise GABA levels is actually a ketogenic diet. And that's not to say that you need to eat keto to get enough GABA, but if you do eat keto, you will have more GABA. And interestingly enough, there were the people who developed the ketogenic diet at the Mayo Clinic in the 1920s. Their hypothesis was that diabetic ketoacidosis causes coma because ketones are anesthetics. And if you overdose on the anesthetic, you go into a coma. And so they thought that you could use what, like the phenobarbital was the drug that was around back then. It's a barbiturate. It's essentially an anesthetic. And you can use basically a mild anesthetic to stop seizures. And so they thought, okay, well, ketones appear to have this mild anesthetic effect. Maybe we can develop a diet that is going to raise the ketone levels. They knew that fasting raised ketone levels. So they said, how can we mimic fasting to leverage that? Interestingly enough, they are right. You can anesthetize. There's a study showing you can anesthetize tadpoles completely with ketones, just through the same test that you would test a new anesthetic that you're going to use for surgical procedures.
Wow.
And so my guess is that the normal physiological role of ketones is to feed your brain when you're fasting. Mm-hmm. When you're fasting, your energy intake is low. Your brain consumes a massively disproportionate amount of your energy. And so if you anesthetize the brain slightly so that you stay functional, but your energy expenditure in your brain goes down, then you're going to be able to survive for longer when you're fasting. So that's my guess as to why that works that way.
Yeah.
But suffice it to say that ketogenic diets raise GABA levels. Now, you might not want to be on a ketogenic diet. You still want to have a healthy amount of GABA. Well, there are a bunch of things that come into play there, but the biggest one out of those is vitamin B6. So having enough vitamin B6 is probably the nutrient that stands out the most as relevant to GABA production. And then it's worth noting that your electrolyte balance is going to play a critical role in your removing glutamate at the synapse to take it out and then allow GABA to kind of play its function. So electrolyte balance is going to be super important in GABA function. And then there's actually GABA in.
Can you explain that just a little bit more in depth?
So all the neurotransmitters are deeply dependent on sodium and potassium for carrying out their function, but they are also deeply dependent on ATP, magnesium, sodium, potassium, and chloride to regulate how much is at the synapse, which is the space in between the neuron that is communicating to the next neuron and the neuron that is receiving that communication. And so if you don't have enough salt or energy, you are not going to be able to clear glutamate from that synapse. And that's going to both decrease, that's going to be needed to reduce the excitation, which is an important part of allowing the inhibition of GABA to become predominant. But also you make GABA inside cells from glutamate. And so it plays into that as well. And then there's GABA in foods. So in terms of food that have their own GABA, wheat germ, all right, so there's fermented foods, but which are highly variable. And then if you look at non-fermented foods, wheat germ is 160 milligrams of GABA per 100 grams. Barley is 95 milligrams. Black soybean milk in a cup of that has, or in 100 milliliters of that has 542 milligrams of GABA, which is very high. And to put this in perspective, when you're looking at GABA supplementation to achieve results like calming your fears or helping you deal with stress, you're looking at 100 milligrams to 800 milligrams. And so when you're looking at these foods, like anything over 100 milligrams is in the therapeutic range. So wheat germ at 160, barley at 95 is really close. Black soybean milk at 542 is right in the middle of that. Red mustard leaf at 178 is very significant. Azuki beans at 201 milligrams. White tea is at 50 milligrams. So if you doubled your dose of tea, you'd get 100 milligrams. And then potatoes vary from 16 to 61. So it's quite variable, kind of like fermented foods, but you could, if you're eating potatoes as your major starch, you could easily hit 2 servings a day, which oftentimes would get you over 100 milligrams. And so obviously any of those foods could be combined And so if you select from like a handful of those foods, you could easily make your way up to 800 milligrams of GABA, which is one on the higher end of the doses that have been used in human studies.
Mm-hmm. Or you can supplement directly with GABA itself.
Yeah, you can take GABA for sure.
Yeah, which is a rare case where you can sort of, or maybe, I don't know if it's necessarily that rare. There might be some other examples, maybe with dopamine as well. But you have a case where you can take that neurotransmitter directly into your body in supplemental form. Now, on that subject, there's some controversy as to whether GABA taken in orally passes through the blood-brain barrier or not, and whether it actually enters the brain. And, there's, I've read some recent literature reviews, and there seems to be just some debate. That current understanding, from what I understand, is that nobody knows for sure. There's no consensus on that. But there's also some people, for example, Dr. Tatis Karazian, who uses or suggests using oral GABA intake as a test for blood-brain barrier permeability, with the idea that if you react to it, sort of like, I think it's something to the effect of, if you take a bunch of GABA, maybe 500 milligrams or a gram or something of GABA, and then 30 minutes later you become agitated or anxious, then that is suggestive of blood-brain barrier permeability. I know I brought this up.
GABA shouldn't make you anxious anyway. GABA should calm you down. And so GABA is making you anxious. That's probably much more likely an electrolyte imbalance or an energy dysfunction that is causing the electrolytes at the cell membrane to become inverted, that is causing GABA to have an excitatory effect instead of an inhibitory effect. I want to back up first.
In other words, you're skeptical of the idea that
I'm skeptical of numerous components here, but I want to back up and make this even more controversial.
Okay.
So I have no idea if this is true, but I do know that that is theoretically possible. The GABA so the blood-brain barrier is between the brain and the blood. The blood-brain barrier is not between the brain and the peripheral nerves. And there is a thing that is known to happen called retrograde axonal transport, where things can traffic. There's actually a trafficking system inside the axon. So this has nothing to do with the nerve impulse. So, and for people who don't know neuroscience, an axon carries a signal of a nerve cell from one place to another. That signal is carried through ions of sodium and potassium that are jumping back and forth in the membrane. The stuff inside the axon has nothing to do with that nerve impulse. It is known that there's a whole trafficking system inside the axon. Things can be transported backwards up the axon. So I think it'd be great to do a research study to see if it's the case that GABA from food travels backwards into the brain through the vagus nerve, because that could happen. The vagus nerve innervates the gut. So no one's shown that to happen, I don't think, but it could. So the blood-brain barrier might not be relevant. Now, at the blood-brain barrier, it's a bit controversial whether GABA crosses. To be honest, all of these things are contextual over like Tatis Karazian is saying, you can have more or less blood-brain barrier permeability. I think probably a little bit of GABA gets into the brain, not a lot through the blood-brain barrier. But so I'm not super skeptical that the amount of GABA that gets in is a function of blood-brain barrier permeability. As I just said before, like, I don't know if the blood-brain barrier is the point at which GABA is getting into the brain, so it might not be relevant at all. But if we assume it is, then his idea kind of makes sense up until the point where he's talking about anxiety. GABA shouldn't be causing anxiety in the brain. Mm-hmm. The histamine getting into the brain is going to cause anxiety. GABA is not one of the wakefulness / alertness / anxiety in excess chemicals. And so GABA can act as an excitatory neurotransmitter. Like glutamate should cause anxiety if it gets into the brain. If GABA is causing anxiety, it is acting like glutamate. It's acting as an excitatory neurotransmitter most likely. And that is known to happen in certain types of epilepsy. The reason that happens is a dysfunction of the energy metabolism and the balance of ions across the cell membrane. And so there's a different, deeper problem if the GABA is causing anxiety. The GABA is not causing anxiety because it crossed in the brain. It's causing anxiety because it crossed in the brain and did something really that it shouldn't do in the brain.
Okay.
That it didn't do that is a totally different story.
Got it. Okay, so let's say GABA does not cross the blood-brain barrier to any significant degree.
Yeah.
I know you alluded to the possibility of interaction with the vagus, but what is, if it does not penetrate through the blood-brain barrier, it just sort of enters into our bloodstream and then GABA goes into our brain. We do at the same time have lots of research showing that it is having very clear effects on things related to brain function. So what is the sort of accepted mechanism of how those effects are happening?
There is no accepted mechanism of it. What we know is that doses between 100 and 800 milligrams a day have shown to do obvious things that affect the central nervous system. So they change brainwave patterns to higher alertness, lower anxiety patterns. They've been shown to suppress. So that there was a study where they took people who were afraid of heights and they had them walk across a very long suspension bridge. And then they measured the suppression of their immune system that resulted from the stress spike. And GABA supplementation prevented that. And then there's animal studies showing that oral GABA increases central GABA, meaning GABA inside the brain. So I don't think anyone's done a labeling study to show that the molecule of GABA that you ate wound up in your brain. But there are studies showing in animals showing that if you eat GABA, there is subsequent to that, there's more GABA in your brain. And there are studies in humans showing that eating GABA has things that you would expect GABA in the brain to do, carrying out in human effects. So it's sort of a moot point, like how it gets there.
Right.
But
it either is penetrating through the blood-brain barrier to some small degree, at least, or it's interacting with something in the gut, like the vagus, to indirectly affect brain function. And
and that could theoretically
translating to higher GABA here.
Yeah, the most controversial thing I could suggest is that it's actually traveling up the vagus nerve. The least controversial thing I could suggest out of everything probably is that it's having an inhibitory effect on the vagus nerve that is translating to an inhibitory effect on something else that is translating into eventually a rise in central GABA through a cascade of nerve cells talking one to another.
Okay, got it. So the last thing here is you're a fan of GABA supplementation for some of the reasons you've alluded to. Some people use it to help promote sleep onset, but you're also talking about daytime use to help promote alertness and decrease anxiety. Are there any other?
I don't really see GABA as relevant to sleep. I think that if someone's getting help from, if someone is getting sleep benefit from GABA, they're treating something else that's interfering with their sleep. So they're treating anxiety, or they're treating their mind racing from one thing to another. But I don't think that it's right to really see GABA as a sleep inducer. It isn't a sleep inducer. Like it's not, and I don't know, maybe a sleep expert could give you, maybe someone would challenge me on this, but I don't think one of the major changes that you see when someone goes to sleep is all of a sudden there's tremendously more GABA in their brain. What you're seeing is that the biogenic amines go like way, way down to zero. And what you're seeing is the parts of your brain that are involved in, excuse me, in taking sensory information and translating them up into the conscious awareness. They just form a loop back on each other so that there are these like just little loops that run and they shut out the outside world. And that's mainly a result of low voltage calcium channels that allow one neuron to communicate something intracellularly with another neuron without ever firing. And so what stops firing is the biogenic amines. And then these other neurons, they get stuck in this loop where they never fire. And when you're talking about GABA, you're talking about something that fired and released GABA to inhibit the next neuron. And I'm not saying that that doesn't happen in sleep. I'm just saying that it's not a major feature of sleep versus not sleep to have way more of that type of firing, I don't think. And so I think if someone's benefiting from GABA on their sleep, it's way more likely to be that they're benefiting from something else that's equally applicable in the daytime. Like there's some people whose mind's always racing. They're probably going to be more focused at work if they take GABA, and they're probably going to sleep better at night if they take GABA. Some people super high anxiety, they're probably going to have less depressed immune system in the day, and they're probably going to have better sleep at night if they take GABA. Those are just people that need to take GABA, I think.
Gotcha.
Or need to address some underlying thing causing them to need to take GABA.
Gotcha. Okay, last thing just to wrap this up. So GABA, foods rich in GABA, GABA supplementation. What do you think of herbs? Things like kava, valerian, lemon balm, and some of the other herbs that are suggested to act on the GABAergic pathways. Are you a fan of any?
I wouldn't say I'm a fan or not a fan. I just don't know that much about herbs. So there's lots of medications and then natural versions of those medications that are going to act on GABA receptors, and they're going to act the same way as taking GABA or supporting GABA nutritionally, just with a different potential potency. So like there are people who take benzodiazepines to sleep and get GABA action out of them. It calms them down. It kind of shuts them off, and they wind up sleeping. Really high risk of dependency. Very, very potent. You take something else that acts on GABA receptors, not as potent, not as much risk of dependency. The ideal thing is to give your body the support to make its own GABA, because that way you don't have the risk of dependency, but it's also going to be harder to see a result. It's not going to be as potent. There's going to be people where their problem isn't that they weren't getting enough nutrients, it's some other defect, and they're going to have to use something stronger. And if you can get away with kava, do the kava. If you really need the benzos, you might have to take the benzos. But it's a spectrum and a trade-off of potency and reliability of effect versus risk of dependency and dysregulating the pathway.
Okay, gotcha. And did we cover at all? Did you cover any specific nutrients that impact on GABA synthesis, or just GABA from foods itself?
Yeah. So I mentioned vitamin B6. I didn't go into full detail, but I think B6 is the one that's definitely most likely to be involved, and that's mainly because you make GABA from glutamate. So if you're thinking about the complete synthesis of GABA, you're starting with glucose and you're incorporating things like niacin, magnesium, ATP, various things that get you to glutamate, and then you are getting to GABA. But the one thing that's really getting you from glutamate to GABA is vitamin B6. Yeah. And if you think of someone who's revved up all the time, their GABA is low. It's not because they're not making enough glutamate. So I think vitamin B6 just sort of stands out as the most relevant thing there.
Yeah. Awesome. Chris, well, this has been another masterclass, Masterjohn masterclass. I thank you so much for your time. This has been a lot of fun for me. I really enjoy the podcast that I do with you, and it's some of my personal favorite podcasts. Chris, thank you so much again. This has been a blast, and we'll have to do another 5th podcast at some point, maybe in a few months.
For sure, man.
Awesome, man. Enjoy the rest of your night, and great chatting with you.
Yeah, you too. Same.
Hey there, this is Ari again. One more quick thing before you go. Just make sure to subscribe to our YouTube channel, The Energy Blueprint, and also make sure to subscribe to this podcast on your favorite podcast platform, whether that's iTunes or Stitcher or anything else. I hope you guys enjoyed this interview, and I will see you again next week.